So actually, if you go into the EU Soil Observatory, it's called, you see a map, and in this map, you see the healthy status of the soil. I mean, this is just to give you an estimate on which may be the problems that you may have in soil salinization, soil erosion, soil compaction, reduced soil fertility, or too much of phosphorus. So there are several aspects that are mapped, but this is just an indication. We know, we work in agriculture, that every field is different, and to assess the status of a given field, you need to actually go there, because there is the historical management on that field, the crop rotation, and it may be or it may not be that actually that field is affected by those degradation processes. But roughly, it's an indication. So when we, in the map, go and select any given location in the map, we will find the whole list of soil degradation processes that may be occurring. From water erosion, which under our conditions of Mediterranean heavy rainfall events is a factor to consider, especially if we are on a slope. It may be accumulation of heavy metals, too much or too little of phosphorus, and I will focus on soil carbon and on salinity, because actually with polysulphate and with the combination of polysulphate and compost, we are targeting those aspects more precisely. So also keep in mind that by nature, some soils are saline or are sodic, but we are focusing on actually human-induced salinization and what we can do. If we look this video from FAO, which is about soil-affected soils, there are two main solutions. One is gypsum application, the other one is preferred drip irrigation, localized application to deal with those processes. When it comes to, and then when it comes to irrigation, in this soil health indicator, it is assumed that any place where there is irrigation, there may be actually secondary salinization. This, you know, it is not true, because it depends on the quality of the water you are using. But it's assumed if there is more than 30% of land irrigated, we will have a potential problem with salinization. And then the soil organic matter levels in our calcareous soils is usually reduced, also because of the management we've been doing of the soil, the crop rotation, the little input of organic matter from crop residues, and from soil amendments like compost. The soil types in our conditions, it's soils that normally range between 0.5 meter to 1 meter deep, empty soils, poorly developed soils with a lot of stones. Sometimes we even have a cover of stones. I guess this is familiar to you. So how to manage these soils and to focus on those actually processes of soil degradation, soil salinization and soil organic matter. This was introduced this is our vision in ICL for the soil health promotion, and it needs the overall management strategy, considering the inputs of organic carbon, the balanced crop nutrition, and additional soil amendments like lime or gypsum that can be part of it. And in the end, we are aiming for the soil to keep under a certain level of salinity or below, to keep cation exchange capacity and soil pH, as well as the overall structure that allows the holding of water and the growth of plants. And we are bringing polysulphate. Polysulphate is a unique mineral that it was known from 1 century ago, but it was not available in the market. There is an area in the North Sea, under the North Sea, that ICL is actually mining. It's 1 kilometer under the North Sea, and from the UK, there is the mine that allows access to mine that area. The process of mining is very simple, actually. It's like the usual mining of any rock underground, by continuous actually chopping or crushing the rock. Then the transport, there are shuttle cars, but there are also conveyor belts to bring it sorry, to bring it actually to the hoist, to the lift, where the materials are hoisted to the surface, then crushed, sieved, screened, and split it into different products. Actually, these are the products. This would be the minimum part, the medium part, which is a 1 to 2 millimeters particle size, and the granular part that can be already used as a fertilizer. Actually, any of these three could be directly used as a fertilizer, and currently are being used as fertilizers. This one is also used in blending with other fertilizers, and this the standard in creating compound fertilizers or the compost with polysulphate. So the process I explained, how actually it's mined polysulphate, you see there is the most energy process is actually the ideation of the mine and the pulling up of the materials out from the mine. The rest are all low energy input processes. And that's why, what it was referred to also by Spiros, the carbon footprint of a ton of polysulphate is reduced, is very reduced. Actually, the carbon footprint depends also on how much we produce. This calculation that was referred by Spiros was done 4 years ago when we were producing 700,000 tons of polysulphate. Now ICL is producing 1 million tons. So actually the carbon footprint is even lower because the process has been improved in its efficiency. And then about the salinity index of this product that was referred also by Spiros, if we compare with other fertilizers supplying potassium, we see that with the different indexes, that polysulphate in any of its grade standard for the production of compound fertilizers or granular for the direct application, it's much lower, 1/4 the salinity index with different or half the salinity index depending on which index we are using. This salt index of polyhalite is the name of the mineral. Polysulphate is the brand name from ICL. You can check this one, salt index of polyhalite, a publication for further details about it. So of course, for crops, like I'm referring to avocado, but we have also tobacco, or those soils that are already high in salt levels, and we are trying to minimize addition of salts, polysulphate is the perfect fertilizer. The benefits, I will not go into the detail. Spiros referred there are more than 100 trials. They are all available in the webpage, in polysulphate.com, or in ICL Group, ICL Growing Solutions. You can also find the individual results of each crop. But overall, what we see is in broadacre crops, in arable crops, increasing yield, and in the end, return of investment for the farmer. In cash crops like potato, coffee, tea palm, this is more from tropical regions, because there we also get the benefit of the calcium in the polysulphate, much more in these acidic kind of soils. So there we also see benefits in the quality of these productions. And then in the cash crops, like tomato, cauliflower, onion, broccoli, these are brassicas in many cases, and are crops that take much advantage of the sulfur that is made available by polysulphate. The idea of mixing polysulphate standard with compost has been already always in ICL's mind. And we tried even at field level to do this mixing of a proportion 10 to 20% of polysulphate together with the compost. But actually you see the operation, it's very complicated, and the mixing, well, you get to a kind of product that may be more or less homogeneous depending on how much effort you are putting in the mixing. Then the application is also complicated because it's a compost without any kind of granulation, and it can be done with specific machines. This is for an application incorporated in the soil, but it requires specific machines to apply this compost like any case. And just what we are doing with biosolids is working on these pellet granules that allow a product that contains polysulphate inside all the benefits of the compost, bringing the organic matter, and that it's easy to use by the farmers with increased density from the polysulphate and the spreadability of a pellet or a granule in a better case. So thank you very much for your attention.